The last but important topic of multistage amplifiers is the effect of multistaging on cutoff frequencies and rise time. This is important topic for GATE and engineering services both, because there are numericals from these topics which have appeared in GATE exam, especially in electronics engineering. Fine. So let us talk about cutoff frequencies first. So if you remember, suppose we have a single stage amplifier having frequency response like this. Fine. Say this is flat top, that is flat frequencies. This is first cutoff frequency, that is FL. This is lower cutoff frequency, this is upper cutoff frequency. Fine. But if you remember, because of multistaging, what happens to the gain? Because of the multistaging, gain of the amplifier increases. Because the gain of multistage amplifier is equal to the product of gain of individual stage, or in decibels that is sum of gain of individual stage. So gain increases, but interestingly you will come to know that cutoff frequencies, this is again mid-band gain, this is mid-band not, this is not, this is for multistaging, this is gain at cutoff frequencies in multistage, and this is cutoff frequencies FL star, H star. Due to multistaging, gain of the amplifier increases, but cutoff frequency, lower cutoff frequency increases, upper cutoff frequency decreases. This is the effect of multistaging. So what has happened? The bandwidth which was BW earlier, that has reduced to BW1. So bandwidth of the amplifier reduces. These are important questions for exam. Because of multistaging, lower cutoff frequency increases, upper cutoff frequency decreases, bandwidth of the amplifier decreases, gain of the amplifier increases. Fine. And remember, gain bandwidth product remains same. These are few questions. There are objective questions from this topic also in GATE as well as engineering services. So you should remember, gain bandwidth product remains same. Due to multistaging, bandwidth decreases, lower cutoff frequency increases, upper cutoff frequency decreases, and gain of the amplifier increases. Fine. But interestingly, what happens? Why it is happening so? Because in case of multistaging, when you talk about the cutoff frequency, so in one stage, this is the stage, this is the next stage. So when you calculate the cutoff frequency for this, I have to consider the capacitances of this stage as well. So while calculating the cutoff frequency of one stage, the lead capacitances, the parasitic capacitances, and Miller capacitances of the next stage should be taken into account, and that result into change in cutoff frequencies of the amplifier. So these are some of the points you should remember. So now, interestingly, in multi-stage amplifier, suppose there are a number of different types of amplifiers which are connected in cascade to form a multi-stage amplifier. So suppose if you have a 10 number of amplifiers, so this will be having different cutoff frequencies FL1, FL2. If the different stages of the amplifier are having different cutoff frequencies, so talk about, suppose you are talking about 3-stage. Take example of 3-stage amplifier. Fine. So in 3-stage amplifier there will be 3 frequencies. Frequency of the stage, lower cutoff frequencies I am saying, lower cutoff frequency of the stage 1, lower cutoff frequency of stage 2 and lower cutoff frequencies of stage 3. So there will be 3 different cutoff frequencies associated with 3 stages if the different amplifiers are not identical in multistaging. Fine. Similarly, all 3 will be having different upper cutoff frequencies. I'm repeating, if suppose I'm saying I'm having 3-stage amplifier in which all stages are different. Stage 1, stage 2, we have 3 stages. All stages are not identical, or you can say all the stages are having different amplifiers, but all are forming one single multi-stage amplifier. So say for this amplifier, lower cutoff frequency is FL1, upper cutoff frequency is FH1. For this, lower cutoff frequency is FL2, upper cutoff frequency is FH2. For this stage, lower cutoff frequency is FL3, upper cutoff frequency is FH3. Now, what will be the overall lower cutoff frequency? That's important point. If you talk about overall gain is equal product of gain of individual stages, provided these are not interactive stages. Fine, I'm just assuming. Fine. But how will you select the lower cutoff frequency out of 3? This is important question from examination services point of view, or from engineering services point of view, or from examination point of view. Fine. So out of 3 frequencies, these may be having different values. Say FL1 is like FL3, then FL2, or it can. I'm just saying. So the cutoff frequency, the highest cutoff frequency among these 3, highest of among these 3, highest, suppose FL1, FL2, there will be 3 different cutoff frequencies, because every stage will be having their own frequency response. So highest of lower cutoff frequencies of the all 3 stages will be overall cutoff frequency of the multi-stage amplifier. I repeat, suppose FL1 all these 3, then FL1 will be the overall cutoff frequency of the multi-stage amplifier. I repeat, please remember, this is very important question. For example, if you talk about the overall function of this, if you remember the low pass filter, what is the transfer function? 1 plus F by FL1, right? Then in 1 plus JF by FL2 and so on. This is the case for higher frequency. In case of low pass case, that means at high frequency. But in case of lower side, 1 by F, FL2 by F and so on. But these will be simply multiplied, and these are nothing but poles. This is one pole, this frequency defines one pole, this frequency defines another pole. So cutoff frequencies are nothing but poles of the amplifier. Poles of the amplifier. Fine. So which is largest? This one is largest. So the pole, largest pole, you can say, largest pole among all the poles of the amplifier at low frequencies will be giving me overall cutoff, lower cutoff frequency. So large, or I can say largest cutoff frequency of all the 3 stages is the overall lower cutoff frequency of the amplifier. This is a very important question. Please remember this. Now let us talk about upper cutoff frequency. In case of upper cutoff frequency, it is reverse. Reverse means the smallest among all these 3. Smallest among all these 3 is overall upper cutoff frequency of the amplifier, and these are also poles. But in for frequency response, what do we get? How do we get it? F by FX2. Fine. So these also represents pole. For these are poles at high frequencies, these are poles at low frequency. So largest pole for low frequencies is the overall lower cutoff frequency of the multistage amplifier. Smallest pole at high frequencies is overall upper cutoff frequency of the amplifier. It means if you have multiple amplifiers, so smallest of upper cutoff frequency is overall cutoff frequency, largest of overall cutoff frequency is the overall cutoff frequency, or largest among all cutoff frequencies of the stages is the overall cutoff frequency of the amplifier. Please remember, this is very important question. So it means largest among all lower cutoff frequency is overall cutoff frequency, smallest among all upper cutoff frequency is the overall upper cutoff frequency of the multi-stage amplifier. This is very important from examination. Who are taking or having different paper, they can note it down, otherwise read my text which is uploaded on discademy.com. I repeat, channel name of the channel, you know, that is www.discademy.com. This text is free of cost there. Complete theory which includes all these points what I am speaking is given sequentially properly in that text. You can just for examination, you can just go through that text. Now let us talk about the next one. Suppose these are not identical. These are not identical. In that case, you have understood the concept of overall cutoff frequency, overall lower cutoff frequency, overall upper cutoff frequency. But if these stages are identical, then for n stage amplifier, overall upper cutoff frequency of each stage, because now I am taking identical stages. When all stages are, if stages are identical, in that case, if all the stages are identical, overall cutoff frequency then FH into 1 by n minus 1. You should remember 2 power 1 by n minus 1. This is overall upper cutoff frequency. And similarly, overall lower cutoff frequency for identical n number of stages is 2 power 1 by n minus 1. What is overall cutoff frequency of each stage? Because all are identical, Fh is overall cutoff frequency of each stage. Fh is overall or rather than saying overall, Fh is upper cutoff frequency of each stage because all are identical. Fl is lower cutoff frequency of each stage because all are identical. These are very important for engineering services and for GATE exam. You must remember directly. Fine. So there was question based on it, but I'll be taking that example separately. Let us see another topic. And one more thing here, if you multiply this factor will be cancelled. Fh star into Fl star is equal to Fh into Fl. It means product of the cutoff frequencies for and individual stage will be same. Should remember this one. Fine. Now, suppose I have n number of stages having different rise time. It means if all stages are not identical, in that case there is expression for rise time. The rise time, I am repeating now. The rise time, overall rise time and number of stages is equal to TR equal to 1.1 and TR1 rise time of the stage 1 square plus rise time of the stage 2 square and so on, rise time of nth stage. This is overall rise time of the multi-stage amplifier with no unidentical or with the stages which are not identical. Fine. There where T rise time of nth stage is what? 0.35 divided by the cutoff frequency of nth. Already talked about this formula. in frequency response. You can just go through the frequency response and you will find there this formula, rise time of amplifier. I have derived the expression as well. Fine. So rise time of any stage, TR1 is what? 0.35 by FH1. TR2 is what? 0.35 by FH2. And what is FH? FH is upper cutoff frequency of that stage. Fine. Upper cutoff frequency. You should remember it. Fine. So I can find overall rise time of multi-stage amplifier if I know the rise time of each stage, or if I know the cutoff frequency of upper cutoff frequency of each stage. This is again there can be question in engines resist prelim especially, or maybe in GATE as well. Fine. So because there were questions based on the overall frequency response in GATE exam, so I cannot ignore the question in GATE exam based on this formula as well. Fine. So you should remember, you should mark up these formulas directly. These are very important from examination point of view. Now let us talk about the concept of dominant pole. I have already shown you one thing, that every amplifier has a transfer function upon what? V naught upon V in, that is equal to, if you talk about lower frequency, at low frequency it is something like gain divided by 1 plus J, that is S by omega L. This is the transfer function of the amplifier at high frequencies, because when S is in numerator, that is the frequency response at high frequencies, and when it is in denominator, when S is in denominator, that is the gain at low frequencies. At low frequencies, your amplifier behaves like high pass filter, so this is the transfer function of high pass filter. At low frequencies, your amplifier behaves like low pass filter, and this is the transfer function of low pass filter. You can go through my video and my text on frequency response of the amplifier where I have talked about these things. Fine. But in multi-stage amplifier, I don't have single frequency, rather I have multiple frequencies, and I will be talking about upper frequency. So FH omega H1 as 1 plus omega H2 by S, 1 plus omega H3 by S. This is the type of transfer function of an amplifier, multi-stage amplifier having multiple poles. Why? Because every stage has its own cutoff frequency. So every stage has its own cutoff frequency, and because of that I have this type of the transfer function, because in multi-staging we have cascade combination, and in cascade we simply multiply the transfer function of each stage, and there will be multiple poles in the transfer function of the amplifier. And when there are multiple poles in the transfer function of the amplifier, in that case, how you determine the overall cutoff frequency? Fine. So that overall cutoff frequency becomes important when we know the cutoff frequency of the each stage. So there is concept of dominant pole. Concept of dominant pole means every factor in denominator gives one pole, because when you take LCM of this, there will be S cube in the denominator, S and S cube in the numerator, and we have these factors in the numerator. So this is one pole, this is second pole, this is third pole. So I have multiple poles, say omega H1 on negative axis, of course, S plus omega equal to 0, so omega H1, if you a little bit remember control system. Fine. So it gives multiple poles on the omega axis like this, and of course that depends on not necessarily that this is farther. This may be farther, this may be farther. That depends on the relative values of omega H1, H2. It may be like this, omega H2, then omega H3, omega H1, and so on. That depends on the relative value of the poles of each stage. But there is concept of dominant pole. What is that dominant pole? If these poles away from the nearest pole to j omega axis. This is what the pole nearest to j omega axis. If all the poles to j omega axis are 2 decade away, or you can say if these poles are 4 times of this, omega h2 h1 is more than 4 times omega h2, and omega h3 is 4 times omega h3. Fine. Then the pole nearest to j omega axis, which is smaller at least by a factor of 4, smaller than these by factor of 4, that pole is known as dominant pole in case of high frequency response. In case of high frequency response, the pole which is nearest to j omega axis and smaller by at least factor of 4 in comparison to other poles is known as dominant pole. Fine. In case of lower cutoff frequencies, it is other way around. A pole which is at least 4 times greater than other poles, 4 times greater than other poles is dominant pole. So concept of dominant pole should be very clear to you, because it is theoretical type of question for engineering services prelims. So pole which is smallest for high frequency response, the poles which is smallest and by at least a factor of 4, that's a dominant pole. But in case of low frequency pole, the pole which is larger at least by factor of 4 other than in comparison to other poles, that is dominant pole. So dominant poles are totally different for high frequencies and for low frequencies. For high frequencies, the lowest pole is the dominant pole, which is less by at least by a factor of 4. And in case of low frequencies, the pole which is greater by at least by factor of 4 in comparison to other poles is the dominant pole. So decade means by factor of 4. Factor of 4 gives you is called decade. Fine. Now, so here let us talk about now the dominant pole will be giving me overall cutoff frequency. So this, if this is by this pole is at least less by factor of 4 in comparison to this, then this is called dominant pole. So overall cutoff frequency of multi-stage amplifier is equal to this dominant pole. This will be giving me overall upper cutoff frequency. Fine. I hope it is clear now. Fine. But if this pole is just equal to this, just 4 decade away, you can say if it is just 2 decade away, not 4, it is just 2 decade away, exactly 2 decade away, then in that case your upper cutoff frequency is 0.94 times this frequency. FH2, FH2 means I am talking about dominant frequency. So upper cutoff frequency is equal to dominant frequency if all the poles are more than 2 decades away. And your upper cutoff frequency is 0.94 times the dominant frequency if dominant frequency is just that is 2 decade away, exactly 2 decade away. And if these poles are more closer, it means this is factor even less, these are more closer to this. If all the poles are closer to each other, not away, in that case overall cutoff frequency is given by the formula we talked about, the rise time. The overall cutoff frequency when all the poles and which frequency, overall upper cutoff frequency is equal to 1.1 times under root 1 by f1 square plus 1 by f2 square and so on plus 1 by fn square under root. This is the expression of upper cutoff frequency when all the poles are close to each other. So I have given you 3 concepts. When dominant pole is at least more than 2 decades away, the cutoff frequency is equal to dominant frequency, dominant pole. If dominant pole is exactly equal to 2 decades away from another pole, then cutoff frequency is 0.94 times the dominant frequency. and if all the poles are closer to each other, there is no dominant pole. In that case, the overall cutoff frequency is given by this. There was question numerical on this concept in engineering services prelims. You are given cutoff frequency of the two stages of the amplifier, you have to find the overall cutoff frequency of the amplifier, and this is the formula you have to use. So this can be another question from in engineering services or maybe in GATE exam, but most of the questions are in engineering services from this particular topic. But you should remember all the concepts very clearly and carefully. Now, there are certain 2 to 3 points again from an objective type point of view. In multi-stage amplifier, input stage is mostly used to give high input impedance. Intermediate stages are mostly used to give high voltage gain or to provide gain of the amplifier, and output stage is used to provide the low output impedance. I repeat, in multi-staging, in purpose of input stage is to provide high input impedance, purpose of the output stage is to provide low output impedance, and purpose of the intermediate stages is to provide high gain. So most of the gain in multi-stage amplifier is provided by intermediate stages. That's what I'm trying to say. Input stage is used for impedance matching, output stage is mostly used for impedance matching. Fine. So these are some of the points you should remember. And there is one more point from engineering services point of view again. In the emitter bypass capacitor which is used in multi-stage amplifier, RC coupled amplifier and transformer coupled amplifier, the resistance connected across emitter, this RE, this resistance connected across the emitter resistance is emitter bypass capacitor. This emitter bypass capacitor is made of, that is basically electrolytic capacitor. The purpose of electrolytic capacitor is basically this give this gives high capacitance per unit volume. So size will be small. Fine. So electrolytic capacitors are mostly used, and this is again one objective type question in engineering services exam, not for GATE. So these are some of the points. I repeat, if you want to study theory on this, whatever I am saying, either you note down in your copy or you can refer my notes, my theoretical notes, which are uploaded on www.discademy.com. You can access this text free of cost. You don't need to pay even a single penny to anyone. That is freely available at this website. The name of the website is the name of the channel itself. So you can get all texts of these videos free of cost there, just for revision purpose. Fine. Thank you very much for watching the video, and this finishes your multi-stage amplifier. In my next video, I'll be talking about the next chapter, that is compound circuits. Compound circuits are what? That is current, mirror, then cascade combination, cascode combination, and these type of circuits I'll be talking about. Darlington pair I'll be talking about in next chapter, that is compound circuits. So just wait for my next video to come. Thank you very much for watching the video.